Good morning. Welcome back. So, yesterday's class, I think there seems to be a confusion between the stack array I need and the stack data structure. The confusion was like it is homogeneous set of elements. Yes, the one I declared, which was an array int stack of 8 elements, that is the size of it was 8 elements. It was a homogeneous set of elements wherein I could only enter integers. I performed push operation, that is I inserted an element. I showed you the push technique on that integer array, which was the homogeneous set of elements, right? And I also, I think, mentioned yesterday that you can have heterogeneous data, but then if you want to store heterogeneous data in one array, you cannot store all like int str. But then if you want to implement stack with arrays, and within that stack you want to store heterogeneous data, then you need to maintain a union so that you can store different data types. Getting it? So please don't get confused with stack as a data structure and stack as an array there. You can name it as different. So here afterwards I'll be using a different name so that there will be no confusion. There, yes, it's a homogeneous set of elements only because I had declared it as int, so I cannot store float or char there. But then you don't create a data structure only for a certain data type. So if you want to implement stack with arrays and you want to have different kind of data, that is heterogeneous data, then you need to maintain an union so that you can store different data types. And then along with this you need to have a stack top variable and an array to keep track of data type of each array position, because it is different, right? So let us not complicate it, because you don't have that complicated thing. You have only push and pop operations. So push is nothing but to insert an element into a stack, you use push. To delete an element from the stack, you use pop. Push and pop are functions because insertion is a function and deletion is a function. And your insertion into an stack is called push. Deletion from stack is called pop, right? And then you have to follow a particular order. The order is last in, first out. So many people had also doubts about difference between an array and a stack, right? So can you tell me the difference? First difference is, like, see, stack I can store multiple different types of data, but then in one array I can store only one kind of data. Yesterday I had created an array only wherein I did the push operation. In a stack, if you want heterogeneous data, then I told you what you have to do. Okay, so let us keep it simple. Yesterday's class we did a function program. I showed you how to push in an element. In that, what did we do? We had a pointer called top, which initial value of -1, and then top will keep track of the last element pushed in. In an empty stack, there was no elements, and then I declared an integer, one integer int stack of 8 elements, and then on that I did the push operation, exactly how push works. And once the stack is full, we also displayed the overflow condition. So let us take a generic example. For example, a pile or a stack of plates. You have around 15 plates stacked on one another. So how would you take that? Definitely you will not lift all the 14 plates and start taking from the last plate down. You start taking from the topmost, right? You take the topmost plate, and as and when people go on taking it, it goes on reducing. And once you keep and wash it, you don't keep it on a opposite direction. You just directly keep one on the other and it goes on piling, right? That is how the stack works. That is the last element which is inserted, like you take the last topmost plate from the pile of or a stack of plates, same way the last element which was pushed in or inserted would be the first element which is deleted. That is how it works. Whereas in array, it allows me random choosing, like I can directly enter a value at a location 5. I need not start from 0 to 5. Whereas in stack, it has to be from 0 to 5 only. Random access it does not support. Even the deletion, I can delete an element in the fifth location or fourth location in an array, whereas in stack the deletion or the pop operation will happen only from one end, that is the top of the stack. Even the insertion and deletion happens from one end only, that is the top of the stack. So insertion, that is the element which is pushed in, the last element pushed in would be the first element which is popped out, that is deleted. Let there be no confusion here. So that is how it is different from arrays, right? Because array allows me random, whereas stack allows me it has to be in insertion, and deletion happens only from the top of the one end only, which is the top of the stack. So if you want to delete the first element, you should have deleted all the top elements. Like for example, if I have 5 elements in my stack, to delete the first element you should have deleted or popped out the top 4 elements. Directly it will not allow me to delete the or pop out the first element. That random access is not allowed. Whereas in arrays, we also did the deletion at a given position, right? I can delete an element at a given position, whereas in stack, it will not allow me doing that. That is, it follows the order last in, first out. That is, the element which was inserted or pushed in the end is the element which is popped out or deleted first. That is, the last element in would be the first element to go out. So please don't make any confusion here. Stack as a data structure is heterogeneous. Yesterday I implemented the push operation on an array called stack. We followed that operation, how actually the push works, and that is an integer stack, whereas it is a homogeneous set of elements. So if you want to have heterogeneous data, then you need to maintain in union and also the top element to keep track of the location of the data type of this elements. Getting it? Please don't get confused. I think there is a lot of confusion between data structures and arrays. Array is homogeneous. Stack, yes, heterogeneous. But then I told you yesterday also, like you can create, I'm creating an integer stack here. You can have a float or a you can have a float. When I'm using array based, you can have float, character, whatever. But then yesterday's class I was doing a integer only. I had declared the array name as stack, in stack of 8. In that I can only have integer elements, and I followed the push operation. How exactly the operation is done? The top element to begin with would be -1. Top is equal to -1, which is a pointer. It will be -1 in an empty stack, and then I go on incrementing it and pushing in the elements. So when top becomes n minus 1, it will, and then you try to push one more element, it will give you stack overflow condition. And then I think there was another doubt like stack of 1, 2, 3. Many students thought it is multiple stacks I have declared. It is not that, it is a subscript, right? Stack of 1 would be the element at the position 1, because it was like how I use an array, like that only I was doing it. So the generic example what I told you is a pile of plates. The last plate would be the first to take. Like if you have a pile, you always take it from the top. You don't start taking the plates from the bottom. The same way the stack works, the topmost element would be the first element to be deleted or popped out, and the insertion or push and pop happens from one end only. So please take out this confusion. Don't get confused. Still, if you have, please write your questions in the chat box. I will explain it to you. Yeah. But then you don't have to worry about the union and all, because that complicated you don't have. We will make it a simple push, pop and peek operations, wherein push is insertion and pop is deletion. We will write algorithm, we will write a program. When I write the program, I will show it to you how exactly it works. Getting it? And then I will tell you where it is used, what are the operations of stack. Some of the applications would be polish notations. We will be doing that. That is how to evaluate an expression in a stack, and then evaluation of postfix expression. Then reversing a string. How can you reverse? Yes, I keep on inserting the string. The first character inserted will go to the 0th position, 1, 2, 3, 4, 5, and when you extract, the last element inserted would be the first element gone. So the element at the location 5 would be is extracted first, then 4, 3, 2, 1, 0. This way you get the reverse of a string also. Then recursion. These are some of the examples of stack. Please have a look. So hopefully now you've understood the difference. So what is an array? An array is a data structure wherein the elements are identified by the array index, whereas stack is an abstract data type wherein the collection of elements are there and the operations are push and pop. And then an array can contain elements of the same type, whereas stack can contain elements of different types. But then again I said, if you want to have different types in array based implementation, you should implement it using a union. Yesterday's program, I had created a stack of collection of integers, wherein int stack of 8 is a collection of integers only. That is why I use the word homogeneous. And then, or you can have multiple arrays like that, wherein you can use the push operation also. Then basic operations in an array are insert, delete, modify, traverse, sort, search, merge. All these are the operations of an array, whereas the basic operations of stack are push, pop, peek. All these pushes, nothing but insertion of an element inside an array. Again, you need to follow the proper operation which I showed you yesterday. And then pop is to delete an element, and then random deletion it will not allow. On deletion, that is push and pop, happens from the top end only, and the element which is pushed in the end, that is the last element pushed in, would be the first element popped out. Whereas in array, I can randomly delete any element in between. So here any element can be accessed using the array index, whereas in stack only the topmost element can be removed at a time. Can you get that? Hopefully now I think I have cleared the confusion of yesterday's class. We can continue now. Still, if you are not able to understand, please do write it in the chat box so that I will try to clarify. I am very sorry for the confusion because the name was same. That is, the name of the array was also stack and the data structure was also stack. So there was a lot of confusion there. So now hopefully we have cleared the confusion. Yes, array, it is array based implementation. I will use a subscript and all is same, but then the operation, that is the insertion and deletion, should happen only from the top end. Insertion is the pop push function, and then the pop is nothing but the deletion or extracting an element, and random extraction cannot happen. That is, if you want to delete an element at the position 5 in an array, I need not delete the topmost. Like suppose there are 8 elements, I want to delete the 5th element, I don't have to delete the 8th, 7th and 6th element, whereas in a stack I need to delete it that order only. That is, the topmost element can be deleted or removed at a time, only the topmost element, because the deletion and the insertion happens from the top end only. Hopefully I'm now clear, but still if you're not able to, just ask me. Please have a look. This is the implementation of stack in two ways, using arrays, which is static implementation, and using pointers, which is dynamic implementation. So array based implementation we will be doing. Static is memory is allocated during compilation time, and dynamic is during runtime. When I do linked list, I will speak about the nodes. So item 1, 2, 3, and arrays are one next to one another, where linked lists are logically connected to one another, wherein you can see this part which has an arrow is nothing but a link part which points to the next node in the list, and each one of this is called a node. So when we do linked list, you will understand it in a better way. Please have a look at this. So now we'll go through operations on stack. Stack, it creates a new stack that is empty. Push item. Item is a parameter, that is, you're going to push in an element. What has to be pushed is the item. That is, it adds a new item to the top of stack. Getting it? Why is it top? Because the push and the pop happens from one end, that is the top of stack. Pop removes the top item, which was the latest item pushed in, would be the element removed. That is, last in would be the first out. Peak returns the top item from the stack but does not remove it. See, pop removes the item, it returns. Like you can see, is empty tests whether the stack is empty, and size returns the number of items in the stack. Please make a note of this. See here, stack conditions. There are two conditions. One is stack overflow and other one is stack underflow. So we did overflow condition yesterday. Overflow is if you are trying to insert or push an element into an already full stack. That is, if you are trying to push in an element into an already full stack, that is, there is no place left in the stack, then that condition is called stack full overflow. That is, if you are attempting to push in an element into an already full stack, such condition is called stack overflow. Whereas if you are trying to pop is nothing but delete or extract, right? If you are trying to pop an element from an empty stack, that is, when there are no elements, you cannot pop out any element, right? If you are trying to pop out an element from an empty stack or remove an element from an empty stack, such condition is called underflow. When I do push, I need to check for overflow condition. That is how top is equal to n minus 1, and then if it is true and I am trying to push in one more element, it will give you overflow condition. Yesterday we did that. Pop is when top is equal to minus 1. When top is minus 1, there are no elements in the stack. When top is minus 1, if I am trying to delete or pop out an element, that time it will be underflow. So when you are inserting or push operation is done, you need to check for overflow condition. When pop operation is done, you need to check for underflow condition. Please have a look. This one yesterday we did. Yeah, I named it as stack, the name of the array, like int stack of this thing. See, push is a function. It takes in one argument. What is that? The element or the item. Directly you can pass the item as ABC, or you can pass a variable which holds that item. Like I can ask the user to enter the item and then I can push it there. So stack, empty stack, and that is why top is not pointing to any place in the stack there. And then I have pushed in, push A, this operation is done. So it goes here, see here, it does not go to this top location, it goes to the bottom, like bottom, then up, 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 then it goes to the top. So it goes to this location and top is pointing to the last element or the latest element which is pushed in. So A is the latest one which is pushed in because that is the only element it is pointing to. And then again I am pushing an element B. So push B, where then top would be pointing to B because that is the latest element. So now suppose I want to pop out A. Directly I cannot pop out A without popping out B. So it is the last in, first out. Which is the element which was last here? B is the element which was last entered. That should be the element which is popped out first. Without popping out B, I cannot pop out A. Whereas in an array, I can directly take in the element in the subscript location, right? Whereas in a stack, I cannot pop out A without popping out B here in this example. So next I have pushed in an element C. So the latest element pushed in and the element which has to be popped out. The last element pushed in, element which has to be popped out first. Top would be pointing to that. So C, then if I want to pop out A, then first I need to pop out C, then B and then A. Please have a look. And please don't get confused here. Next, we will write this algorithm like push operation. I need to do. Please make a note of the statement of this algorithm. Then we'll start with the algorithm. So hopefully you have finished writing the question. Now, what is the question? Like push is an operation. What you're going to do, wherein push is nothing but insert an item into the list. Stack is an array that contains, see here again, stack is an array. Yesterday's example also I had told you stack is an array. I had taken stack as an array. So I had told it was a homogeneous set of elements. So here also item, since stack is an array that contains n item elements and top is a pointer to the topmost element. What is the topmost element? The element which was pushed in the end. The last element which is pushed in is definitely the topmost element. If there is only one element, that element becomes the topmost element. If there are two, then the second element is the topmost element. That is, the element which is pushed in the end is the topmost element of the array. Top would be pointing to that last element which was pushed in. That is the element which was pushed in the last. is the top would be pointing to that. If there are 5 elements, it would be pointing to the fifth element. Like first you will push in the first element, second, third, fourth, fifth. So fifth element top would be pointing to. Item is the element which is inserted, and the procedure of inserting item into the stack is push. Getting it? Now we'll write the algorithm. Please make a note of it. Step 1. So, first what did we do yesterday? We checked for the overflow condition. Before pushing in the element, I need to check whether there is any place in the stack or not. If I am trying to push in an element with the already full stack, then it will give me an overflow condition error. It should show me stack overflow, right? So, check for overflow. Okay, how do I do that? Check for overflow. How did I do? I checked if the top element is equal to n minus 1, where n is the total number of elements. N minus 1. Check if top is equal to n minus 1. If it is true, then what should I do? I should write this one, print stack overflow, and I should exit. Print stack overflow and exit. Right? Check for the overflow. If top is equal to n minus 1, where n is the number of elements in the stack. Total number of elements is n. If top is equal to n minus 1, because 0 to n minus 1 is n elements, print stack overflow exit. If this is not true, what should I do? If this is not true, then what should I do? What did I do? I incremented top first. When you're pushing in, you need to increment top first. Correct? Because top would be pointing to the topmost element. If I don't increment it, then it will rewrite or it will overwrite on that element only. So you need to increment top to a location where there is no data. So increment top. Increment top. How do I do that? Top is equal to top plus 1. That is how I increment top. Correct? That is, check for the overflow condition. If top is equal to n minus 1, stack overflow exit. And then if it is not true, first increment top. That is, top is equal to top plus 1. Step 3. Step 3, what will I do? I need to insert an item, right? After incrementing top, I need to insert the item or push the item. Push item. How do I push item? I have to write stack of top is equal to item. Okay. After that, return. So this is my algorithm for the push operation. First, what is the array name? That is, the name is stack of n elements on which I am going to do the push operation, and item is the element which has to be pushed. So step 1, first whenever you are doing push, you need to check for the overflow condition. What is overflow condition? Overflow condition is nothing but if you are trying to insert into a already full stack, it will give you a overflow condition. Print stack overflow exit. Otherwise, if there is still place in your stack, you need to increment top so that it will point to a vacant location. You will not be rewriting on the existing element and then push it. How do you push the item? Stack of top is equal to the item. So it will get written. Item would be pushed at the top location, that is stack of top. So in that location, when I say stack of top here, top is a subscript value or the index value. In that location, it will get pushed in and then written. Please have a look. Hopefully you have understood the algorithm. Now we'll write the program for push operation. So program to perform we'll be writing a program to perform push operation. I will write the program and I will explain exactly that push function. When it happens, I'll tell you how it works. Okay, first you write down the program hash include iostream.h conio.h hash include ctype.h. I'll be using a character function, built-in function, so that is why I'm including ctype.h header file. After that, class, the name of my class is stack. Okay, private, let me say, like, what are the variables I would need in private? I would have to have, before that, let me declare the size of my stack. So I will use hash define size 5. Okay, my size of my stack is 5. So you can give any size there. You can give 1000 also. Fine. Int yes of. So on this array S, I will be performing the push operation. So what will S contain? It will contain integer elements because I have declared it as int. So in my stack, I will push only integer elements in this program. Don't get confused with the data like elements in stack and what I am going to push in this. Okay. And then I have a variable called, called top. Fine. Top and size. S is an array of size. So what is size? 5. So S is an integer array of 5 elements. And then here I have created a constant here. That is, I have defined a constant sizes 5 top, and then in public section I will have stack, wherein I would be giving the initial value for top, then void push is the function to which I am going to pass an integer variable to push into s. So I am going to pass an integer variable void print. That is, it is going to print the elements of a stack. This completes my class. So in my class stack, I have in the private section two data members. One is an array S of type integer, and the size of the array is 5 because I have declared size as 5, and top. So then in the public section, I have a constructor stack, then void push int, that is function declaration of push. In push you pass one item, right, which I need to push in. Since I am going to push it into yes, I will need a integer value. So I have given it as int, and then void print, which is going to display the details or the elements in my stack. I will show you the execution of this also. After that, I need to write the definition outside. How do I do that? Stack scope resolution operator, stack, then top is equal to -1 to begin with. Yes, because when there are no elements, top would be -1. After that, let me write the push. How do I write? Void name of the class to which it belongs to, scope resolution operator, then push int item. Okay, I'm going to push an item, so it would be that. Then what is the first step here? I need to check whether for the overflow condition, correct? So how do I check it? If top is double equal to size -1, correct? Because 0 to n minus 1. So here n is size. 0 to 4. What is size? 5. 0 to 4 would be total 5 elements. Correct? So I will say this. Then what will I write? Cout stack full overflow, right? Enter. So after that, I need to return. So if the stack is full, then if top is equal to size -1, then you cannot add any more elements into the stack. So I will say stack full overflow endl return. If there is some space in my stack, what should I do? I should write it in else. What will I do in else? First thing is increment top, right? So top ++. After that, what I should do? I should now enter the push in the element. So what is the name of the array? Yes, of top is equal to item. Where do I get item? From the calling function. If I call this from main, I will pass item to this as an argument. I am passing item, an integer value, as an argument to this. After this, I will just, for your user's reference, I will say element item. Actually, the value of the item would be present here. pushed successfully. Okay. So once the item is written, it will show you which item got pushed successfully. After that, nothing. My job is done. I will close my else. I will close my function. So what did I do here? If I checked for the overflow condition, before that, this is the argument, like actual formal parameter is one which I pass it from main. This one is the actual parameter in the function header. Sorry, formal parameter is in the function header, that is item is the formal parameter, actual parameter is the one which I pass from main. So I am passing item from main, and then what I will do, I will check whether there is any space in the stack or not. I'll check for the overflow condition. If top is equal to size -1, then stack full, return. It will print me this and it will return back. Otherwise, it will go to the else part top plus plus, because top would be pointing to the topmost element. So you need to increment it so that it will move one position upward to a vacant place. Then you can write. After that, yes of top, because I have declared yes as a integer array of 5 elements, right? So s of top is equal to item. See out element would be printed as it is. Item is whatever value you passed, that would be printed there and pushed successfully. There ends my stack function. After that, I need to write my display function, right? Void, then stack scope resolution operator. What will display do? It will print me C out and the elements of stack are for int I is equal to 0, I less than or equal to top till the top. Okay, because whatever top is pointing to, that would be the last element. I plus plus C out yes of I backslash T to give tab spaces, and I will close my this thing, close my function. So display function C out and del, the elements of stack are for I is equal to 0, I less than or equal to top, I plus plus. C out Si, that is Si is 0th location, whatever is there, it will print. After that, it will see here I am not deleting it, I am just printing it. So it will print it. Getting it? The stack contains, or I will say the elements of stack. I am just printing it. I am not deleting. Deleting happens from one end. That is, if you are popping out, you need to pop out from the last. That is, it follows the last in first out principle. C out si backslash t. After that, I need to write my main, right? Void. Okay, I need, correct. Main, open your bracket, clear screen. After that, what should I be doing? I should say char ch is equal to, let me say y, then I will have int item, because I need to pass an integer variable or an integer value, right, when I call this. So I can name it as item or I can name it as xyz. It doesn't matter. Only thing is the number and the data type should match. So I will say int item. After that, what will I do? So I have to ask. Before that, I have to put it in a loop because I want the user to, at a time, he can insert. Like I want to push in 4 values. I don't have to again rerun the same program again. If I put it in a loop and call the function multiple times, it should be able to work. So how do I do that? I will use a while. See, when I do pop, that time I will write a menu driven program, with which case here I will just use only one push. So I will write while ch is double equal to y. Okay, c out, enter the item to push. Okay, and c in item. Okay, then what should I do? Enter the item to push. I entered the item, C in item. Now you have to call the function push, right? So before that, what should I be doing? Before that, I should have created an object for the class, because only using object I can call the member functions of the class. How do I create it? I create an object. Stack was the name of the class, and SOBJ, let me name it as a object name. When you write this statement, the stack function gets executed and top gets initialized to -1. Enter the item to push C in item. After that, I will say, I will call the function, yes, so bj dot push. Okay, so item is the variable I am passing. I have taken in, I am passing. After that, I want to call the display function also, because every time I push, I want to see the stack elements. Fine. Dot. Okay. Now, after pushing in, taking in the value and pushing in, I have to ask the user, do you want to push in one more element? So how will I do it? C out and okay. Do you want to push in one more element? Okay. C in CH. Okay. Now CH is equal to lower CH, because it is case sensitive. Let me convert it into one case only. Now suppose CH is true, I will continue. Otherwise, I will write a message, end of stack operations, and I will exit. Let me do that. Okay. So here, if CH is double equal to Y, then I will say continue. That is, continue with the loop. Else, what will I do? C out and end of stack push operations. Okay. Then get ch. This is the end of my program. So what I will do is here I am having a hash defined size 5. So I have a variable size with, sorry, it's not a variable, it's a constant. Size will not change its value. The value assigned to it is 5. So int yes of size is basically yes of 5 and top. These are the data members. In the public section, I have push, to which I am passing an integer value. One integer variable I am going to pass to this, and then I'm going to print it. These two are the functions. Okay. Let me see. Did I write the print function? No, I wrote the display. Sorry, make it as print because I had declared it as print over there. So it should be print only here. Okay. So what will I do first? Stack. I'm initializing the variable my top is equal to -1 in constructor. So whenever I create an object, this will execute. After that, void stack, that is int item if top is equal to size -1. What will happen? It will give you a overflow condition. Size is the maximum number of elements. So 0 to size -1 would be the elements actually where it would be stored. So if top is equal to size -1, it is overflow and you will return. Else increment top, store the element in the top location, that is yes of top is equal to item. Where do I get the item? I got it from the calling function. Then element, I'm just printing this, the element item was pushed successfully. After that, in the print, I start from the 0th. In printing, I'm not popping out or deleting any elements. I'm just printing the elements of stack. So I is equal to 0, I less than or equal to top, I plus plus, because top would be the pointing to the last element, right? That is why it should be either less than that or equal to that. After that, I have ch is equal to y and int item. I created an object here. After that, while ch is equal to y, enter the item to push. C in item. I'm asking the user to enter the item to push, and then I'm calling the function for push here, and I'm passing the one integer value. Like item will have whatever the user enter, it will be there, and it is also of type integer. Then I'm calling the display function because I want to see every time an element is pushed, what are the elements of the stack. Then I'm asking the user, do you want to push in one more element? Okay. ch, I'm taking in the ch value to lower ch because I'm having ch is equal to lowercase y. Since it is case sensitive, if as an user I entered the uppercase y, for me it means yes, but system will not execute. So if it is true, then I'm continuing. So again the while loop gets executed. Else what will I do? End of stack and exit. I will go out of this end of stack operations and I am exiting it. Get ch, end of my program. You don't have to write get ch there because anyway I exited it. So please make a note. I will show you the execution of this also. Hopefully I have noted down when I wrote it. We'll see the execution of the program. So see here, hash defined size 5, stack private size top I. There in the for loop only I I declared I here, so I have declared it here. It doesn't matter. Void push int item, or I can say only int. When I actually define it, I can write the name of the formal parameter. Void display stack top is equal to -1. Void stack push item If top is double equal to size minus 1, stack full, overflow and it will go back. Else top should be incremented, then S of top is equal to item. Then cout endl item is successfully pushed. Okay, there ends my push function. Then after that, stack of display. I'm just displaying the elements of the stack. In main, I have char ch is equal to y. Int item, I've created an object for the class while ch is double equal to y while it is true. Enter the item to be pushed in. I need to ask the user to enter the item, take it, then call the function push. I am calling display because I want to see every time an element is pushed, what are the elements. Because I want to do it, I am calling it this way. Then cout endl, do you want to continue? If yes, I'll change it to 2 lower ch because I am checking for the lowercase y. If ch is equal to y, continue with that. Else, what will I say? End of stack operations. Here I haven't called the exit function, so it will, I have get ch here, so it will wait in the output screen for me. Let us run it. Enter the item to be pushed in. So let me say minus 98. 98 is successfully pushed in. Stack elements, it is showing me 98 because there's only one element now. Do you want to continue? I'll say yes. Enter the item to be pushed in. Let me say 5. So 5 is successfully pushed. Stack elements. The first element was 98 minus 98. The next element is 5. So there are 2 elements in my stack. I will say yes. I'll say enter the item to be pushed in. Let me say 8 I need to push in. So the stack 8 is successfully pushed. Stack elements are minus 98, 5 and 8. I will say yes. Let me show you the overflow condition. That is why. Enter the item to be pushed in. I will say 88. Then the elements of the stack are minus 98, 5, 8, 88. So there are 4 elements here. My stack is of 5 elements. So I will say yes. Do you enter the item to be pushed in? So I will say 8. So yeah, minus 98, 5, 8, 88 and 8. So now my stack is full because I have entered 5 elements. Again, if I try to push in, it should give me the overflow condition. So I'll say yes. It will ask me enter the item to be pushed in. Again 88 I want to push in. So it is showing me stack full, overflow. So again it is showing me the what are the elements of the stack, right? There are only 5 elements here. Minus 98, 5, 8, 88 and 8. The last element which I tried to push in, that was again I tried to push in 88. There are only 5 elements in the display function. It is not pushing 88 because the stack is full and it is overflow. So it is showing me that message that you cannot push still more. Again, if I say yes also, again it will show me stack overflow. It will not allow me to push in. If I say yes, it will show me stack overflow and the contents. Like there are 5 elements in my stack. So until I delete, let me try to, like if I say yes, again it will show me overflow. So let me say no, then end of stack operations. Yes, end of stack operations and exit. So hopefully you have understood this. Let us execute once more. So run, enter the item. So 55. Do you want to continue? If I say no, I don't want to continue, It will directly, it is not compulsory that every time you need to enter all the elements, end of stack or push operations, and it is going back. Yes, hopefully you have understood the push function, how it works, and how to call it. We'll close this. Okay. So hopefully you have understood, saw the execution. Your confusion must have been cleared, like what was homogeneous yesterday and what is heterogeneous. So don't, for your exam point of view or the understanding point of view, you should know what is push, how is it performed, what is pop and how is it performed, and what is the traversal, that is the peak operation, as well as what is the difference between a queue and a stack, and what are the array and a stack. So here the homework questions are: define stack, list the different operations possible on a stack, and write an algorithm to push an element into stack. Please make a note of it. Take care, stay safe, see you tomorrow. Bye bye.